Hello everyone, welcome back for our series of quadratic equation, part of the uh, topic that we started for this mathematics series from our channel. So in this session, in continuation from our part 2, we'll pick up a topic related to nature of roots, and then we'll try to go over some of the examples for nature of roots. So let's get started. Uh, So in previous sessions, we have seen that roots of quadratic equation ax square plus bx plus c, where a is not equal to 0, are given by x equal to minus b plus or minus root b square minus 4ac by 2a. So now let us try to study the nature of roots of this quadratic equation, and then in that root, if you observe, b square minus 4ac is under root, like uh, a presentation of a root, where we'll see what the roots or the values of x will be if b square minus 4ac have different set of values. So first case we'll consider is b square minus 4ac is greater than 0. So in this case, what will happen is we generally have we'll get two distinct real roots, which is minus b plus root b square minus 4ac by 2a, and minus b minus root b square minus 4ac by 2a. So when you say like b square minus 4ac is greater than 0, then what is symbolizes on a y-axis and x-axis related graph as you will get a curve of quadratic equation, and then we will get like a curve that cuts the x-axis at two distinct points. So if b square minus 4ac is greater than 0, in such cases, if we try to draw the graph for this first case, what we'll have is, say we have this x-axis and we have y-axis. So either the values will be negative, and when x will be equal to two distinct negative values, so then if you see the curve of the quadratic equation, it's cutting the negative x-axis at 2 points. Similarly, if we have one positive and one negative value of x, then you will see the curve showing like the one part of the curve cutting at the negative x-axis and the one cutting at the positive x-axis. So similarly, if we have both positive values, then it will be cutting the x-axis at the positive side of the x-axis. The curve will be cutting at 2 points on the positive x-axis. So this figure shows that the corresponding curve of the quadratic equation cuts x-axis at two distinct points. Now we'll consider case 2, where the root, which is like b square minus 4ac is equal to, that is the part under that root, which is b square minus 4ac is equal to 0. So when we consider that, then we will have like x is equal to minus b plus 0 by 2a, which is nothing but we'll get x is equal to minus b by 2a. So it means like you will have only one point if we present graphically, where if you see, if it's a negative value that you'll get for minus b by 2a, then it's like on the negative side of the x-axis you will see the curve touching at a 1 point. So it's only that curve of quadratic equation will touch x-axis at a 1 point. Now if we have a b value which is negative, so minus b plus b will or you can get a 0 as b value, so then it's like exactly at the 0 point. When we get the value of x as 0, you will see that quadratic equation is cutting the x-axis at a 0 point. But if we can have a positive value of x and we have a b as positive and a value also having a positive, then it will touch at one point on the x-axis or the positive side of it. So this is when b square minus 4ac is equal to 0. Now the third case, what could be the situation is where the value of b square minus 4ac is less than 0. So now what will happen is here again we will have no real roots. So they are imaginary roots. So because of that, you will see on graph that the curve of quadratic equation a square minus a square plus bx plus ac is not touching x-axis at any point. It could be a negative side of the x-axis or at the center where we have the xn. So it will be touching the y-axis, but it will not touch the x-axis. And then on the positive side also we'll have a curve which will not be touching the x-axis. So these are the three cases, and now we will pick up the example to see that how it helps us to uh, simply identify and then find the discriminant of the quadratic equations, which we have called based on the three cases like b square minus 4ac. If it is greater, then what will be the values? So the b square minus 4ac is the discriminant of some of the values that will come based on the final outcome of that. So let's pick up this. So find the discriminant of the quadratic equation where we have 2x square minus 4x plus 3 is equal to 0, and hence find the nature of its roots. So as a solution, what we can see is it's a standard ax square plus bx plus c is equal to 0 equation where if you compare to the equation given, a is equal to 2, b is equal to minus 4, and c is 3. Therefore, the discriminant, which is like a minus b square minus 4ac, will be equal to minus 4 square minus 4 into 2 into 3, which is equal to 16 minus 24, which is nothing but minus 8. So when it says like minus 8, so it's less than 0. So as we have seen our three cases, like if the value of b square minus 4ac is less than 0, it will not have any real roots. So based on that, we can conclude like this equation 2x square minus 4x plus 3 is equal to 0 will not have any real roots. Now we'll pick up another example where we are trying to find the discriminant of the quadratic equation 3x square minus 2x plus 1 by 3 is equal to 0. To just check like first and at the end we'll find the nature of its roots. So to start with, first we'll see like a compared to the standard equation when we are trying to give a value for a. So the given example like 3 is nothing but a is equal to 3 and b is equal to minus 2 and then c is equal to 1 by 3. So now when we apply these values on the discriminant, which is b square minus 4ac is equal to minus 2 square minus 4 into 3 into 1 by 3, which is equal to 4 minus 4, which is equal to 0. So that concludes that a square minus 4ac, sorry, b square minus 4ac is equal to 0. Hence we will have two equal roots. The given equation has two equal roots, which is minus b by 2a minus b by 2a, that is 2 by 6. 2 by 6 is nothing but 1 by 3. So when you again represent on the graph, it will be like one point where the x-axis will be touched, as we have seen in the other cases. So that's we have covered as an example. So thank you everyone for watching us. We'll come up with more additions to this, and we'll be back with some other topics as well. So till then, thank you everyone for watching. Please do subscribe our channel and do not forget to click on the bell icon. Thank you, everyone.